This is the Chapter 5 and 6 test review. We have 34 problems, and I'm just going to go straight into it, and I'm going to do these problems relatively fast, just breaking everything down. Here I go. Problem 1. If P of x equals 6x minus 7, Q of x equals 5x squared plus 4x minus 3, and R of x equals 6x squared minus 3, find the following. A, find R of x plus Q of x. So I'm going to take the R of x function, this stuff, and add the Q of x function, this stuff. Okay, so that's my plan, and I'm jumping in. Here I go. Well, the R of x stuff is 6x squared minus 3, and I'm adding the Q of x stuff, which is 5x squared plus 4x minus 3. All right. So now I need to combine any like terms. For example, these are quadratic terms. They can be added together. 6x squared plus 5x squared gives me 11x squared. All right. So now I look at the linear stuff. Well, this doesn't have any linear stuff. This has a linear term. So this is plus a positive 4x, right? So I'm going to add 4x. And then I look at the constants. Negative 3 plus negative 3 gives me a negative 6. And this is the result of addition of R of x plus Q of x. Next, I'm asked to find P of x minus Q of x. So I look at the P of x stuff right there, and I subtract the Q of x stuff right there from it. All right, so here's the setup. That will equal 6x minus 7 minus 5x squared plus 4x minus 3. Great. Now, here's the thing about subtraction. You need to distribute the minus sign into all three of these terms of this trinomial, right? So this becomes a minus 5x squared, minus 4x, and also plus 3 right there. All right. So that's an important feature. So I'm going to go ahead and combine any like terms. First, I see a negative 5x squared. That's the only quadratic term, right? Negative 5x squared. I'm going to write it here first. But then I have a 6x and then a minus a 4x. All right. So 6x minus 4x is a positive 2x. And lastly, I have a negative 7 and a minus negative 3. So this becomes a plus 3. Negative 7 plus 3 is negative 4. Great. So there we have it. We have just simplified P of x minus Q of x. And now this last piece says find 5 times R of x plus 3 times P of x. All right, so we're going to multiply 5 to the R of x function and multiply 3 to the P of x function and add them together. So here I go, 5 times R of x, which is 6x squared minus 3, plus 3 times P of x, which is 6x minus 7. All right. So yeah, I'm going to distribute this 5 into both these terms and this positive 3 into both these terms. And let's go ahead and see what we get. 5 times 6x squared is 30x squared. 5 times negative 3 is negative 15. 3 times 6x is positive 18x. And 3 times negative 7 is negative 21. And so now I look for any like terms. Well, there's the 30x squared. It's the only quadratic term. There's the positive 18x. It's the only linear term. But these are constants. Negative 15 minus 21. I can combine them together to make negative 36. And there I have it. I have found the result. Great. That was problem 1. Let's move on to problem 2. And it asked me to simplify this expression. The expression 2 times 5x plus 2 minus 7 times 3x minus 3 equals what? Well, let's go ahead and distribute this 2 and distribute the negative 7 into both of these terms. And so this will equal 2 times 5x, which is 10x, and 2 times 2, which is positive 4, and negative 7 times 3x, which is negative 21x, and negative 7 times negative 3, which is positive 21. There we go. And now, lastly, I'm going to combine linear terms, 10x and negative 21x, to make negative 11x. And I'm going to combine positive 4 plus 21 to make a positive 25. I have simplified this expression. It equals negative 11x plus 25. I'm moving on to problem 3, which asks me to evaluate x to the 5th times x to the 4th, and it says it equals x to the n for some n. What does n equal? Well, you might recognize x to the 5th times x to the 4th is the product rule of exponents. I can add the exponents of 5 and 4 together, and I get x to the 9th. Okay, so n is 9. That's what n is. Okay, so I just use the product rule of exponents, adding them together to get the same base. Great. Problem 4. Write the following expression in the form x to the n, assuming x does not equal 0. Simplify your answer as much as possible. Great. So I see the product rule for these bases that are the same, and the product rule for these bases that are the same. And once I apply the product rule twice, I may apply the quotient rule, right? So this is x to the 8 plus 6 on top, and x to the 5 plus 1 on the bottom, because yes, this is x to the first. So I'm applying the product rule. So I now have x to the, well, 8 plus 6 is 14, divided by x to the 5 plus 1 is 6. There you go. And now I see the quotient rule. The quotient rule says that I can take the top exponent and subtract the bottom exponent if the bases are the same, and yes, they are. So I'm going to say that this is x to the 14 minus 6, which equals x to the 8th. And I'm done. So all this stuff right here, it all simplified to x to the 8th, all by itself. All right, moving forward, problem number 5. Simplify this expression. And I see, this monomial right here, and it's multiplied by this monomial right here. It can be good to, if everything's multiplied, which it is, to reorganize things. Like I see negative 1/4 can be multiplied with 24. So I'm grouping my coefficients together. And then let's group the x stuff together. X to the negative 3 times x to the negative 4. And then let's group the y stuff together. Y to the 10th times y to the negative 1. All right, so this might help you to see that, hey, I can just multiply negative 1/4 times 24, which is negative 6, right? And if you needed to, you could say, well, that's what's 1/4 of 24? 24 divided by 4 is 6, and there was a negative in front, so it's negative. And now I can use the product rule on the x's and the product rule on the y's, so I can say, hey, this is multiplied by x to the minus 3 plus negative 4. Negative 3 plus negative 4. And you could immediately say, well, negative 3 plus negative 4 is negative 7. So let's just write that. So I have x to the negative 7th. And now we multiply that with y to the 10th times y to the negative 1. So we're going to add the exponents together using the product rule. And 10 plus negative 1 is 9. So I can write, 9 right there. Now, you may recall from our discussion on properties of exponents that we cannot have a negative exponent in our final result. But to make a negative exponent become the positive version of that exponent, we just put it in the bottom of a fraction, right? So there's a fraction right here. This is all divided by 1. And if I want to, I can flip the x to the negative 7 and put it in the denominator of this fraction. Okay, and it becomes x to the positive 7, and I'm done. This is the answer. Moving on to problem 6, simplify this expression. And it says, 30, a to the negative 1, b to the 9th, divided by negative 5, a to the negative 6, b to the negative 2. Now, when you're dealing with these exponent rules, you can take different approaches, and that's okay. Your approach might be a little different than mine. But in the end, I know that I'm going to have a fraction. And I know that 30 divided by negative 5, if I take just 30 and I divide it by negative 5, that gives me a negative 6. And that's going to go on the top because, 30 is bigger than negative 5. This is 30 over negative 5, which reduces to negative 6 over 1, right? It's a reducible fraction. Okay, but we're going to make the 1 invisible. because we're going to be multiplying it with other things. Now, if I see a negative exponent, I can flip it to the bottom. Or if there's a negative exponent on the bottom, I can flip it to the top and they become positive. So I can make a to the negative 1 be a to the positive 1 if I put it on the bottom of the fraction, and a to the negative 6 becomes a to the positive 6 if I put it on the top of the fraction. Now there's a b to the ninth on the top of the fraction, and there's also there's a b to the negative 2 on the bottom. So I'm going to put it on the top to make it b to the positive 2, like this. And this is all legit. We did legit stuff just now. It was awesome. And now what we're going to do is take the a to the 6th divided by a to the 1st, and we're going to use the quotient rule, right? How many more a's are on top than on bottom? Well, there are 6 on top, there's 1 on bottom, so there's 5 more on top than on bottom. And so I'm going to write negative 6 times a to the 5th. Okay, so a to the 6 minus 1 is 5. And then b to the 9 times b squared, I can use the product rule on that to make b to the 9 plus 2. And 9 plus 2 can be simplified to 11, right? 9 plus 2 is 11. And so there's nothing left on the bottom. It's the invisible 1 is on the bottom. And when I divide by 1, I can just make it invisible. And I have this as my final result. Moving on to problem number 7. Write the following number in scientific notation. And the number is 3,900. Now, where's the decimal place? It's right here. And if we're going to write it in scientific notation, the decimal place has to be moved over so that it is after the first significant figure. The first significant figure is the number that's not 0, starting from the left. The first number that's not 0, starting from the left, is the number 3. So this is the first sig fig. We always put the decimal in scientific notation after the first significant figure, the first sig fig. Now, the question is, how many places do I have to move the decimal where it currently is located to get to where I want the decimal to be? And that is how many spaces? 1, 2, 3 spaces. So we have to move the decimal 3 places to the left. Okay, and 3,900 can then be written in scientific notation as 3.9 times 10 to the third. The amount of places that I move my decimal is the exponent. And if I'm taking a larger number and making it look smaller, I have to raise it to a positive exponent. Okay? Now, if this was a really small number that I was trying to make bigger, then it would be a negative exponent. All right, so you have to be careful. You have to decide, am I taking a bigger number, making it smaller, and writing it in scientific notation? Okay, then I need a positive exponent. And you could confirm this in your calculator. If you type 3.9 times 10 to the third in your calculator, then it will tell you the answer is 3,900, the exact value that we just started with, right? It'll tell you it's 3,900. Great. Well, sometimes we have to do this stuff in opposite direction. So instead of writing a number in scientific notation, we have to take a number that's in scientific notation and write it back in its original form. And that's what problem 8 is about. So let's write the following number in decimal notation without using exponents. And it says 8.9 times 10 to the negative 2 power. And you'll notice that that negative 2 power means that this is a smaller number than what I'm starting with. So we would have to take the decimal, and it's currently right here. We would have to move it 2 places over. Okay, so we're moving it 1, 2 placements over and putting the decimal. Any empty spaces get filled with zeros. Okay, so I know that 8.9 times 10 to the negative 2 power is going to be then 0.089. Okay? Now, when you have a number in scientific notation with a negative exponent, that means it's smaller than what you currently see, right? Negative exponent, it's smaller than this. So this makes sense, right? What you wouldn't want to do is do the 2 decimal places to the right. That's not good. That would be 8,900, which is not true. So be careful as you decide what direction you're moving your decimal place. Good luck. Problem number 9, find the product of the 2 binomials. We're going to multiply this binomial times this binomial, which uses a process called foiling. So you can always foil when you use when you find the product of 2 binomials. What does foiling stand for? It stands for first, outer, inner, last. we're going to multiply the first terms together of each binomial, and that's 8 times 8, which gives me 64. Then we're going to sum that with the outer terms multiplied together, which is 8 and 8y. These are the furthest terms away from each other. We're going to multiply 8 times 8y, and that gives me a positive 64y. Now we move on to the inner terms of FOILing. I stands for inner. They're the ones that are closest together. Negative 8y times 8, and that gives me a negative 64y. And lastly, negative 8y times 8y, which gives me a negative 64y squared, right? Because negative 8 times 8 is negative 64, and y times y is y squared. Now, these two binomials are very special because they're the same two terms, right? 8 and 8y, 8 and 8y, but they're opposite signs, negative and positive. Those are called conjugates. And conjugates, when you multiply conjugates together, the outer and inner terms happen to be opposite sign of each other, right? There was positive 64y and negative 64y, and they cancel. And so my answer is 64 minus 64y squared. This is the final answer. Why are all these values 64? Well, because we had 8s multiplied with 8s, and 8 times 8 is 64. So that's why we got so many 64s along the way, but this is the final result. And this, in fact, is the difference of squares. This is the difference of two things that are squared. We talked about that factoring pattern at one point in our lessons. Problem number 10, find the product of the trinomial and the trinomial. So our goal is to take this trinomial and multiply it with this trinomial. Now, what you have to remember when you're multiplying polynomials together is that we want to multiply every term of the first polynomial with every term of the second polynomial. Okay, so I'm going to first multiply x squared with all three of these terms. Then I'm going to multiply 2x with all three of these terms. And then I'm going to multiply 3 with all three of these terms. And I will have gotten it done. Okay, and so here I go. X squared times x squared is x to the fourth. X squared times 4x is positive 4x cubed. X squared times 5 is positive 5x squared. Great. So I have just multiplied all of these terms with x squared. So x squared, I multiplied here, here, and here. Moving on, I'm going to multiply 2x here, here, and here. Okay, so let's kind of start over with my distribution. And here I go, boom, boom, and boom. And I'll show you those results. I get 2x times x squared, which is a positive 2x cubed. 2x times 4x, which is a positive 8x squared. And 2x times 5, which is a positive 10x. Great. So we've done that multiplication. And now we move on to the last term of the first trinomial. And so I am distributing 3 into all of those terms, and I get a plus 3x squared. And I get a plus 12x. And lastly, I get a plus 15. Okay, so if I've multiplied everything correctly, since this is 3 terms times 3 terms, 3 times 3 is 9. I should have 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, I've got 9 terms. And now the last objective is to combine any like terms. So my goal is to simplify as far as possible. Now, the only term that has a fourth power is this term. So it's the only x to the fourth term. Now let's look for the cubic terms. So I have an x cubed here and an x cubed here. Those are the only two terms that are x cubed terms. So I can add them together. So 4x cubed plus 2x cubed is 6x cubed, right? 4 plus 2 is 6. There we go. Now I'm going to move on to the quadratic terms, the x squared terms, right? So I see this term is an x squared term, this one is an x squared term, this one is an x squared term. So I can add them together as like terms. So 5x squared plus 8x squared plus 3x squared is 11x. No, it's definitely 16x squared. There we go. Because 5 plus 8 plus 3 is 16. Now I'm going to move on to the linear terms, the terms with just x in them. And that's 10x and 12x. Are there any others? I do not see any others as I scan through this. 10x plus 12x, that's 22x. And lastly, I move on to the constants. and I scan looking for the constants, and the only constant is 15. So I put a plus 15 right there at the end. Great. So this trinomial multiplied by trinomial results in this polynomial right here. Okay, so remember, as you multiply a trinomial by a trinomial, it will result in 9 terms. Okay, and those 9 terms sometimes can be combined together as like terms. Look for the same variable with the same power to make sure that they are like terms. One thing that was easy about this problem was it was all addition, right? You had all plus signs between the terms of the trinomials. So that made it so we only had addition going on. Something that could make it more complicated is if we had subtraction signs mixed with plus signs. So please watch for that as you attempt a problem like that. Now let's move on to problem 11. Expand the product of the two binomials using the FOIL technique, and I see 10y plus 3 squared. Now this is a binomial that has been squared, and the definition of squaring something is multiplying that thing by itself. You must multiply 10y plus 3 by itself to get this right. And we have to FOIL, meaning we're going to multiply the first, outer, inner, and last terms. Okay, so if I multiply the first terms together, that's 10y times 10y. Well, 10 times 10 is 100, and y times y is y squared. Now I'm going to multiply the outer terms together. 10y times 3, that gives me a positive 30y. Positive 30y. All right, now the inner terms I'm going to multiply together. 3 times 10y, well, that's another positive 30y. And lastly, the last terms get multiplied together. 3 times 3, that gives me a positive 9. And I look for any like terms. It just so happens the outer and inner terms of FOILing, they are like terms in this case that can be added together. So my final answer is 100y squared plus 60y plus 9. There we go. That's the result. So one thing you want to be careful about is you don't want to just take 10y squared and 3 squared. That's not true, right? You don't just take 10y squared and 3 squared. Your answer would be 100y squared plus 9, and so you would be getting these two terms, but you'd be missing the middle stuff. And so you cannot just square 10y and square 3 to say that this is the answer. This is not true. This is not equal. They are not equal to each other. That's bad. Okay? What you do have to do is when you see a binomial squared, multiply the binomial by itself by FOILing, and then you will know you have the correct answer. Moving on to problem 12. Find the product of the sum and difference of two terms. All right, so really the objective is to multiply these two binomials together, but we notice that they're the same two terms, 2x and 3, and there's addition and subtraction between the two terms. So these are called conjugates. And when I multiply these two binomials together, we'll see something interesting about conjugates. 2x times 2x gives me 4x squared. I'm FOILing right now. I just multiplied the first terms together. Now I'm going to multiply the outer terms together, 2x times negative 3, and that gives me a negative 6x. And now I'm going to multiply the inner terms together, 3 times 2x, and that gives me a positive 6x. And then last terms, positive 3 times negative 3 gives me a negative 9. And I look at the result that I have, and I notice that these outer and inner terms of FOILing are the same value with opposite signs. So they cancel each other. Negative 6x plus 6x cancels to become 0. And so my result is 4x squared minus 9. This is the result. And I'm done. I'm ready to move on to problem number 13. Problem number 13 says, perform the indicated division of a polynomial by a monomial. Right, so I have a binomial up top of this numerator, and I have a monomial in the denominator. And when you're dividing a polynomial by a monomial, all you have to do is divide each term by the monomial one at a time. So I'm going to take 18x cubed and divide it by 9x squared, and then I'll move on and I'll take 36x squared and divide it by 9x squared. Great. So if you want to, you can actually separate these out, you could take the first term of the numerator, divide it by, 9x squared, and then subtract the 36x squared divided by the 9x squared. So you could separate it one at a time. Next, let's write the result. So let's keep it really easy for you. Like 18 divided by 9 is 2, right? 18 divided by 9 is 2. And x cubed divided by x squared, there's one more x on top than on bottom. So it's going to result in just 1x, right? X to the first power. I just use the quotient rule, right? X to the 3 minus 2 is x to the first. Now, of course, we can make that first power invisible. And now we move on to the next part, right? So now I'm done thinking about this. It's 2x. And I move on to minus. And then I think about this. 36 divided by 9. What is 36 divided by 9? Well, it's 4. And then what is x squared divided by x squared? Well, they cancel each other. And so this is my final result. 2x minus 4 is the result of dividing, right? So I took this binomial and divided by this monomial. Now, the same thing could happen if you had a trinomial or a quadrinomial, etc. You just take each term of the numerator and divide by the monomial of the denominator. It's that simple. All right, so moving on, this is a recap of what we've done so far, problem 1 through 13, and we're ready to move forward because we have 34 problems that we're going to address. So here's problem 14, simplify the following expression. And here I have 1, 2, 3, 4 terms divided by a monomial, right? This is a quadrinomial divided by a monomial. And we're going to take the same approach here. We're going to take the first term and divide out the monomial. Then there's a minus sign, so minus. And then we're going to take the next term and divide out the monomial. And then we're going to take the next term and divide out the monomial. And then we're going to take the last term and divide out the monomial. All right, so this is the process. And let's just go one at a time. And we're going to say, well, negative 4 divided by negative 2, that's 2. Okay. And then x to the 22nd power divided by x to the 4th power, that's the quotient rule. You can take 22 and subtract 4, and you'll find out that the exponent should be 18. All right, so now we're moving on, and we're going to take 16 and divide it by negative 2, which is negative 8. But there's a minus sign here already, so if I subtract a negative 8, that's like adding 8. So I get a plus 8 there. Yeah, so be careful with your signs, right? 16 divided by negative 2 is negative 8, but there's a minus here, so minus a negative 8 becomes a plus 8. Now, x to the 19th divided by x to the 4th equals x to the 19 minus 4. This is the quotient rule, x to the 15th, because 19 minus 4 is 15. Let's move on to the next term. So 6 divided by negative 2 is negative 3. I have a plus sign, but then because it's negative 3, I'm just going to write it as a minus 3. And then x to the 11th divided by x to the 4th equals x to the 11 minus 4. So that's x to the 7th. And then I look at the last term here. 16 divided by negative 2 is negative 8, but there's a minus sign in front. So if I subtract a negative 8, that's the same thing as adding 8. And then I'm left with an x to the 9th divided by x to the 4th, which x to the 9th divided by x to the 4th is x to the 9 minus 4, and 9 minus 4 is 5. So there I have my final result. As you attempt this problem, please be aware of the signs, right? Be aware of the signs. One thing that you could do if you wanted to in the beginning is you could flip all the signs and make that positive, positive, negative, positive, and then you'll see why I now have positive, positive, negative, positive, right? This is positive, positive, negative, positive. My result was positive, positive, negative, positive. So if you want to do that in the beginning, you can, and then you won't have to worry so much about the signs. But whatever approach you want to take, just be consistent. Problem 15, factor out the greatest common factor. Okay, let's get out some of our factoring skills now. That's what we're going to do over the coming problems. Now, to factor out the greatest common factor out of this binomial, you have to find the GCF, right? The GCF, greatest common factor. Now, I suggest, if you're new to this, especially, creating a list. Like, take the first term, 18x squared, and break it down into its prime factors, right? 18 is 2 times 9, but 9 is 3 times 3. And then x squared is x times x. So I can break 18x squared into 2 times 3 times 3 times x times x. Now I'm going to look at the 30x and do the same approach. 30x. Well, what does that equal? Well, 30x is, well, it's 3 times 10, but 10 is 2 times 5, okay? And then that's times 1x. Great, now that I've found the prime factorizations of both the terms, I'm now going to circle the factors that they share in common. For example, I see that they share a 2 in common, and they also share a 3 in common, and they also share an x in common. Okay, that is all the stuff that they share in common, and that is the GCF. We have just found the greatest common factor. It's 2 times 3 times x. And we'll multiply 2 times 3 back together to get 6x, right? So the 6x is what I'm factoring out of this expression. And I have a binomial left inside, right? So if I take 18x squared and I divide out 6x, well, I'm left with 3x. And we can see that in our list here. 3 and x are the only things left over from 18x squared. So I write it here. And then I have a minus sign because, there was subtraction there. And I didn't factor out a negative, so that minus sign is still there. And then if I take 30x and I divide out 6x, I'm left with 5, right? So there's just 5 left over. And you can see that here in this list that we created. The only thing that I did not circle in red was this 5. And so there we have it. We have factored out the greatest common factor out of this binomial. Let's move forward into problem 16. In problem 16, it says to factor the given polynomial 9x squared plus 45xy plus 5xy plus 25y squared. And I notice there are 4 terms. Boom, 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 boom. 4 terms. And one factoring skill that you have learned when you have 4 terms or 6 terms or 8 terms, any even amount of terms, is to factor by grouping. Okay, so let's practice factoring by grouping. I notice there are 4 terms, and so I'm going to group the first 2 terms together and the third and fourth terms together separately, and I'm going to find their GCF. And I look at 9x squared and 45xy, and I say, well, 9x is the GCF. And what's left when I factor out 9x is an x plus 5y. That's what's left. And then I look at the third and fourth terms, and I say, well, what's the GCF of 5xy and 25y squared? And I think, well, the GCF is, the GCF is 5y. And in parentheses, I'm left with, I'm left with x plus 5y. There we go. So I have just factored the GCF out of this stuff, boom, and I factored the GCF out of this stuff, boom, and I notice that the 2 binomials that are left, they match each other. They're the same thing, x plus 5y. X plus 5y. And if that's the case, factoring by grouping will work. So we take the GCFs that we factored out and we group them into their own binomial. Boom. And then we multiply it by the matching binomial. And this is the final answer of factoring by grouping. Now, factoring by grouping only works if the stuff in the parentheses matches. This stuff matches this stuff, so we could take 9x and 5y and put them in their own binomial and multiply them by the matching binomial. It's this really cool thing. That's factoring by grouping. Great. So now let's move on to problem 17. Factor the given polynomial y squared plus 15y plus 50. Great. So when we factor a trinomial like this, we are going to factor it into two binomials, if it's possible. And we think, what goes at the start of the binomials? Well, this is a y squared leading term. So y times y will make the leading term y squared. So that's why I'm putting y here and here, because when I start foiling, y will multiply with y to make y squared. Now, to pick the other terms that go here and here in the binomials, we need to consider the constant on the right side. So I look at the constant of 50, and I want to find all of its factors. 50 is 1 times 50, but it's also 2 times 25. But it's also 5 times 10. And I think that's everything that 50 is. All right, so I've got 3 sets of factors that I have found. But which set of factors I use depends on what will give me 15 as a result. Can I sum 1 and 50 together to make 15? No, I cannot. I cannot sum them together to make 15. Even if I made any one of the factors negative, it wouldn't work. Now, 2 and 25, can I make them 15 even if I play with negatives? Nope. And 5 and 10, can I sum them together to make 15? The answer is, well, heck yes, I can. So this is the set of factors I'm choosing based on the fact that they have to sum to make this middle value 15. And so I place them here, and they're both positive, so I put plus signs here and here. It doesn't matter if I put the plus 10 here or the plus 5 here. I could have swapped these easily in this case, because in this case, the starting term is just y in both cases. All right, how can you confirm that you factored correctly? By the way, we're done factoring. How can you confirm that you did it right? Well, you can FOIL this and see if it gives you what you started with back, right? Y times y is y squared. Y times 10 is 10y. 5 times y is 5y, and they sum to make 15y, and then 5 times 10 is 50. So when you FOIL these, they give you this back, and you know that you're right. There's no question. Moving forward, let's factor this given polynomial. It's x squared minus 20x plus 100. And when I look at this trinomial, I see something called a perfect square trinomial. So in our lesson, we talked about perfect square trinomials. That's when you see a perfect square on the left side and the right side of the trinomial. You see? So when I see x squared, I think it's the base x, which is then squared. And when I see 100, I think, well, that's 10, which is squared. And so this is the start of confirming that this is a perfect square trinomial. Next, I notice that the middle term is negative 20x. And to confirm that that's correct in a perfect square trinomial, I take the value 2. I always do it, just 2. And I multiply that 2 with this and this, right? X and 10. These bases of the square. And so I do that. I take x and 10. I check. 2 times x times 10, does that equal 20x? And the answer is yes. Yes, it does. So this is the way that we confirm that we've got a perfect square trinomial. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. Is the middle term 2 times the first base times the second base? And the answer is yes. Well, why did I do all of that? Because now factoring is very simple. And here's how you factor it. You take the first base and the second base and put them in a binomial, x and 10. And then you look at the sign right here. If it's plus, then you put a plus. If it's minus, you put a minus. And so the middle term was negative, so I put a minus sign. And then lastly, we square that binomial because it's that binomial multiplied by itself. That is the factored version. Okay? So it's your job. Nobody's going to tell you that this is a perfect square trinomial, but you could always look at a trinomial and decide, is the first and last term, are they perfect squares? And the answer is yes. And if that's true, then you move on and you say, is the middle term 2 times the first base times the second base? And the answer is yes. And so that's why I can move straight into this factoring pattern. So that was problem 18. Let's move on to problem number 19, and we're continuing our factoring skills. Factor the given polynomial 5x squared minus 2x minus 16. And I look at it and I say, is there a GCF? And 2 and 16, they are not, neither one is a multiple of 5. And there's no variable that I can factor out as a GCF. So there's no GCF. And so what I do is I find the factors of the A value and the C value. Now there's two methods. You could use trial and error, or you could use the AC method that we've talked about in a previous lesson. Okay, I'm going to use trial and error. I find it goes faster for me. So what I do is I take the A value, 5, and I find its factors. And oftentimes it's a prime number, which is great. Like 5 is a prime number, so there's only one set of factors, 1 and 5. That makes life easier. Then I look at the C value and I find its factors. So I'm going to list the factors of 16. 1 times 16, 2 times 8, 4 times 4. These are all of the factors of 16 listed. And now I have to think, how can I combine this set of factors with one of these sets of factors to make the middle term negative 2x? And this is the trial and error part. I'm going to create two binomials, and I'm going to put these values with x. These are the coefficients of x, 5x and 1x. All right, so I put 1x and 5x. A lot of people like to put the bigger number first and the smaller number second. That's great. All right, so now that I've set this up, I need to select a set of factors, this one, or this one, that will go here in this location. Okay, and I need to play with signs a little bit because I see this is a minus-minus situation. That means one of my factors will be negative and one will be positive. And so I'll show you my trial and error process. And we have to, as we do trial and error, consider the inner and outer terms of FOILing. Okay, because the inner and outer terms of FOILing are what will combine together to make this negative 2x. And so I start playing with it. Maybe I try like, you know what? I've already found it. I play with 2 and 8. Okay, so here I'm choosing 2 and 8. And I'm going to make the 8 negative. Okay, so the 8 is the one I'm going to make negative. Because this is, once again, a minus-minus situation. I'm going to choose which factor to make negative. And I'm going to put the negative 8 right here. And I'm going to put the positive 2 right here. And I'm just going to see what happens. This is my guess. I've gotten good at guessing, but this is my guess. And so I take negative 8 and I multiply it with x as the inner terms to make negative 8x. And then I take 5x and multiply it with positive 2 as the outer terms to get 10x. And I find out negative 8x plus 10x is positive 2x. And I have just failed at what I'm trying to do because I was trying to get negative 2x, but I got positive 2x. So I did it wrong. Okay? And I actually did it wrong on purpose, because I wanted you to see that placement and signs matter. Because I could actually restart this, and if I switch the signs that I used, instead of minus 8, I put a plus 8, and instead of a positive 2, I make a minus 2, and I try this again, right, inner terms and outer terms of FOILing, then I would get an 8x, right? 8 times x is 8x, and 5x times negative 2 is negative 10x, and 8x plus negative 10x is negative 2x. That's exactly what I wanted. Yeah? Negative 2x. That's exactly what I wanted. And so I have now factored correctly. Okay? And you see how this is a bit of trial and error, right? You need to play with the different sets of factors to see which one will make everything work. And so now that I've done trial and error, I know that this is the correct factoring. Great. Let's go ahead and move forward. And we're going to continue our factoring process with this one. 9x cubed minus 3x squared minus 30x. And when I look at this trinomial, I notice that it has a GCF. Always look for GCFs, always. In fact, the GCF is, you could create a list. You could be like 9x cubed. That breaks down into 3 times 3 times x times x times x, right? You could go through the list process. That's great. A lot of students say that really helps them. Some of you are getting so good that you can see the GCF right out. So in the end, the GCF of these three terms is 3x. That is the GCF that I observe. And if I factor a 3x out, then what's left inside is a 3x squared for the first term, a negative x for the second term, and a negative 10 for the third term, right? So how am I deciding that? I'm actually taking 9x cubed and dividing 3x out of it to get 3x squared. And then I'm taking negative 3x squared and dividing 3x out of that to get negative x. And then I'm taking negative 30x and dividing by 3x to get negative 10. All right, so you're doing like division. You're taking this, dividing the GCF, and getting the result, right? One at a time. Okay, so there you go. Now that we're here, we need to check to see, can we factor even further? Because our goal is to factor completely. And this is a trinomial that is possibly factorable. So let's try to factor it. And I notice there's no GCF left because we already pulled out the GCF. So I'm going to take the A values factors, right? 3 is 1 and 3. It's a prime. And then look at 10, which is 1 and 10 and 2 and 5. Those are the sets of factors for 10. And I'm going to try to combine these with outer and inner terms of FOILing to make negative 1x. All right, so that's the objective that I have right now. That's what my brain is doing and what your brain is starting to learn how to do. And so I'm going to rewrite this all. And I'm going to say, well, I have two binomials, and I'm going to have a 3x and a 1x, right? So the 3x and 1x. And then I decide which set of factors, 1 and 10 or 2 and 5, will work. This is a minus-minus situation, so one of my factors will be negative and one factor will be positive. Great, so let's dive a little deeper. Maybe I try the 2 and the 5. Okay, and yeah, I think I can do that. So I'm going to take the 2 and the 5 right here, and I'm going to make the 2 negative. And I'm going to place that negative 2 right here, and I'm going to place the positive 5 right here. And you'll wonder, why did you decide to do that? Well, because I can see the inner and outer terms of FOILing starting to work, and so can you, right? Because 5 times x is 5x, and 3x times negative 2 is negative 6x, and 5x plus negative 6x is negative 1x, which is exactly what I want. That's exactly what I want, negative 1x. Great, so I have just factored this thing. And so I just showed you that work, right? And I just wanted to show you my method and why I just got what I got when I factored. So there you go, 3x times 3x plus 5 times x minus 2 is the factoring of this stuff right here. Now, by the way, it doesn't matter the order with which you multiply the binomials, right? So you could have had x minus 2 first and 3x plus 5 second. It doesn't matter, but it does very much matter that you place the correct values in the correct locations with the correct signs. All right, so be very careful as you work through those. Problem 21, factor this one, 2x squared minus 11x plus 15. And I first look for a GCF, and I don't see a GCF. So my brain says, okay, time to do advanced trinomial factoring. And so I look at the A value, and the A value is 2, so I say that's 1 times 2. And I look at the C value, and I say, well, that's 1 times 15, but it's also 3 times 5. And those are all of the factors of 15 that I have listed. And then I say, well, I need to create two binomials, and I'm going to put these values with x, a 2x and a 1x, right? 2x and a 1x. At this point, it doesn't matter which order you do it in. A lot of people like to put the bigger number first, Great, that's what I did. 2x is bigger than 1x. But it really doesn't matter at this point. What does matter is your placement of these, right? So this is a minus plus situation. And in a minus plus situation, that tells me both factors are negative, okay? Both factors have to be negative in this case. Let's dive into what it has to be. Well, if I make 3 and 5 both negative, and I choose that, let's play with that. I think I've got it. Let's see if it works. So if I take 2x and multiply it with negative 3 and x and multiply it with negative 5, that should give me negative 11x. But let's check. So the inner and outer terms of FOILing would give me negative 5 times x and 2x times negative 3, negative 6x. Negative 5x plus negative 6x is negative 11x. Hey, it worked. That's negative 11x. Why am I so happy? Because that's what's in the middle of this trinomial right there. You see that? Okay, so I know that I have factored correctly now. I've made the correct choices, and so my factoring is done. That's it. This is my answer. Now, once again, you could have written the x minus 3 factor first, right? You could have written x minus 3 first, and then 2x minus 5 you could have written second. So these could be swapped, and it doesn't matter, but they have to be 2x minus 5 as one of the factors, and x minus 3 as the other factor. Great, problem 22, we continue trying to factor. Okay, so here's another trinomial to factor. Here it is. Okay, I'm going to zoom in. And problem 22 says factor 2x squared plus 5x minus 12. I notice that there's not a GCF, so my brain says, okay, take the a value, find its factors. Take the c value, find its factors. Okay, make sure to find all the factors of a number, right? Every possible factor so that you don't miss which one you're supposed to use. Great. And so now I'm going to create two binomials. My variable is x, so I'm going to put a 2x and a 1x. Why did I choose 2x and 1x? Because these values that are the factors of a, 2 and 1. Okay, now I need to make a decision about which of these sets of factors will work. Is it 1 and 12, 2 and 6, or 3 and 4? Well, I'm going to have to make the outer and inner terms of FOILing make 5x, positive 5x. And so I'm going to just stop and think for a second. And this is the trial and error part. You've got some trial and error to play with a little. One thing that'll help, a plus minus situation means that one of the factors is negative, right? If this is a minus sign right here, one of the factors is negative. And I'm going to just try something. I'm going to try just 3 and 4, and I'm going to make, I don't know, make the 4 negative. Sure. So I'll try that out. So I'm going to multiply the 2x with negative 4 and then the x with positive 3. There we go. So let's see how I've done. I'm going to check it. And I take 3 and I multiply it with x, that's 3x. And 2x times negative 4, that's a negative 8x. And if I add these pieces together, 3x plus negative 8x, that gives me a negative 5x. Uh-oh. I wanted a positive 5x, not a negative 5x. See that? And so it seems like I've chosen the correct values of 3 and 4, but I need to switch the signs. Okay, so if you get the opposite value, right? I got negative 5x instead of positive 5x. Well, just swap the signs. Boom, boom. That means I should have made the 3 negative right there and kept the 4 positive, you see? Great. And now it would produce a negative 3x and then plus an 8x, which gives me a positive 5x. There you go. And so you see my process here that, these sets of factors wouldn't work for me, just the 3 and the 4 would, but I had to make the signs correct and put them in the correct locations. Great. So there was my scratch work down below, and this is the factored version. Moving forward, problem 23. Factor this one completely. And it says x to the fourth minus 12x squared plus 36. And you might be saying, well, I'm used to seeing something like, x squared, right? So up above, x squared and x to the first instead of x to the fourth and x squared. It seems like these variables' powers are doubled, okay? And that actually helps us. We talked in a lesson about substitution, okay? So I'm going to just write that here, substitution. So substitution makes it so that I can replace a variable with another variable. Like I can say that u equals x squared. Okay, so I'm typically going to use the variable u when I substitute. That's very typical in algebra courses. And I'm going to make the variable u equal to x squared. And then I can rewrite this all as, well, x to the fourth. Just maybe I'll make it really clear. X to the fourth is the same thing as x squared squared. Okay, minus 12x squared plus 36. Okay, so just so you know, x to the fourth is x squared squared. And why does that help me? Because I can turn x squareds, any x squareds that I see, into u. And so now I have a u squared minus 12u plus 36. And this is a trinomial, a quadratic trinomial that I can factor just like I'm used to. And so I attempt to factor this, okay? And I put a u here and a u here. And in fact, this is a perfect square trinomial because I see that 36 is a perfect square. Yeah? Maybe it's not. Yeah, it is. Yeah, so this is a perfect square trinomial. And lastly, I would have a minus here and a minus here, like that. And then I recall that, wait, I said that u was the same thing as x squared, right? So u is the same thing as x squared, so I can replace u's with x squareds again. And there's one last thing that you might notice, that I'm multiplying the same thing by itself. This is x squared minus 6 times x squared minus 6. Well, we can write that as x squared minus 6 squared. Because that's a binomial multiplied by itself, we can say that that's the binomial squared. And so that's the simplest format that I would write this answer in. Great. Problem 24, factor the given polynomial. And it says x cubed plus 729. One of your factoring skills you learned this unit was the sum of cubes. Okay, one of your factoring skills, the sum of two things that are cubed. So if I were you, I would rewrite this as, x cubed plus, well, 9 cubed, right? Because 729 is 9 cubed. And you would say, how would I recognize that? Well, look back in your notes, because in your notes we shared with you the perfect squares and the perfect cubes to get familiar with and to know in your heart pretty well. Okay. There's also on the formula sheet for the test the factoring skill of the sum of cubes. So you'll see the factoring pattern, and I'm going to use that factoring pattern right now by creating a binomial times a trinomial. And what goes in the binomial is x and 9, right? So you're going to take those bases that are the things being cubed and put them here and here. And now, what goes in the trinomial? Well, in the trinomial, you take the first term and you square it. Okay, so x squared. And you take the second term and you square it and put it at the end. So 9 squared. Well, 9 times 9 is 81, so I'll just write it as 81. And then in the middle of the trinomial, you will place x times 9. You're going to multiply the two things together. X times 9 gives me 9x. And then you'll say, well, what about the signs that go between everything? And I would say, well, we have an acronym called SOAP. SOAP stands for same, opposite, always positive. Same, opposite, always positive. Well, same as what? Well, same as the sign that we see here. So we have the sum of cubes, but we also have the difference of cubes, which has a minus sign instead of a plus sign. So SOAP tells me, this acronym tells me, well, keep it whatever it is. So keep it the same. So plus, it's the same. Now, O stands for opposite. Opposite of the plus sign is the minus sign, and that goes here. Okay, so opposite of plus is minus. And then the last part here, always positive, meaning that the sign that goes right here is always positive, right? So I have a plus sign in the sum of cubes, right? Plus sign. So I do same, opposite, always positive. There we go. So I have now factored completely the sum of cubes. Here it is. And please look out. Some of you might encounter the difference of cubes instead of the sum of cubes, right? So in that case, if this had been a minus sign right here, then I would have put a minus sign. Let me do it in red. So if this was a minus sign instead of a plus sign, then I'd have a minus sign, same. Opposite would be a plus sign, and then always positive, plus sign. And that's how the difference of cubes would be different than the sum of cubes. But all of the values of the terms would be the same, right? So the term values don't change. Good luck as you do that. Problem 25. Factor the given polynomial 6r cubed minus 24r. And I see a GCF. So always scan, always look for a GCF, and the GCF is 6r. And if you factor out a 6r out of the terms, then you're left with an r squared minus 4. Okay, how did I decide that? Well, I take 6r cubed and I divide out 6r and I have an r squared left. And then a minus sign, and then 24r divided by 6r is 4, just 4. But I always ask myself, have I factored fully? And in fact, I have not, because this right here is called the difference of squares, right? I'll rewrite it so you see it more clearly. So this is 6r times r squared minus 2 squared. All right, we know that 4 is 2 squared. So this is the difference of two things that are squared. And we learned that factoring skill in class. So when you have that, you create two binomials. And you put the bases r and 2 and r and 2. And then between them, you put a plus and a minus, opposite signs. You could have put the minus first and the plus second. That's fine. But they're conjugates. These two binomials are conjugates of each other, right? And so now we have factored completely. We're done. So that's how you factor the difference of squares, right? First, we had to recognize there's a GCF, and then look inside and say, well, that is the difference of squares, and I can factor that into this. Okay, good luck with the difference of squares. So we're moving on to problem number 26, and it says factor the given polynomial, r squared plus 9. And you might say, well, that's not the difference of squares, that's the sum of squares, r squared plus 3 squared. And when we encounter the sum of two things that are squared, it's not factorable. It is not factorable. And if the expression can't be factored, we answer with prime. So that's what I'm going to say. The answer is that this thing that we started with, it's prime. It cannot be factored any further. It's prime. All right, so be careful. The difference of squares can be factored, like we saw on the previous problem, problem 25. You see, I factored the difference of squares, that's factorable. But the sum of squares is not factorable. It is prime. And so now we move on to problem 27. Factor the expression and simplify your answer as much as possible. And I see 64p cubed minus 125. And you would think that these numbers are random, right? 64 and 125, definitely not random because those are perfect cubes. All right? So let me make it really clear for you. This is 4p cubed minus 5 cubed, right? So 64 is 4 cubed. It's also 8 squared, so be careful, right? 64 is 8 squared, but it's also 4 cubed. 4 times 4 times 4 is 64. Okay, so it's really good for you to go from here and rewrite it like I just have right here, right? 125 is 5 cubed. This is the difference of cubes. And so I'm going to rely on the difference of cubes pattern for the factoring. And that's a binomial multiplied by a trinomial. And we're going to put the bases 4p and 5 here and here, right? 4p goes here, 5 goes here. That's a binomial with 4p and 5. Now, what goes in the trinomial? Well, take the first term and square it. 4p squared. Well, 4 squared is 16, and then the p is squared, right? So that's 16p squared. And now take the last term and square it and put it at the end. 5 squared is 25. All right, so what have I just done? I took 4p and I squared it, 16p squared. I took 5 and I squared it, 25. And what goes in the middle of this trinomial is just simply 4p times 5. So take 4p, multiply it by 5. Well, that's 20p. Great. So I've written all of the terms first, and now I'm going to write the signs. And it doesn't matter if I had written the signs along the way, but you see that how this is a minus sign. This is the difference of cubes, right? Subtraction, difference is subtraction. So I'm going to recall SOAP, same, opposite, always positive, as I apply the signs. So this is the difference of cubes, a minus sign, so I'm going to keep it the same for the binomial. Opposite right here, and always positive right there. And I'm done. I have factored the difference of cubes. And so looking back, problem number 24, we factored the sum of cubes, right? The sum of two things that were cubed. Whereas in problem number 27, we factored the difference of two things that were cubed. So watch out for those perfect squares, those perfect cubes. They'll be really useful as you move forward in this course and beyond. Problem 28, solve the equation x squared minus 3x minus 18 equals 0 by factoring. All right, so we have a quadratic equation. Now in class, in our lessons, we learned, hey, we've got to set a quadratic equal to 0 to use the zero product property. And we can factor the trinomial to make solutions really easy here. And so let's try factoring this basic trinomial, right? So I'm going to, put x here and here because x times x gives me this first term x squared. And then I'm going to find all of the factors of the constant, 18. What are the possible factors of 18? Well, that's 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work. Okay, that's it. All right, so we have found all of the possible factors of 18. But this is a minus-minus situation, meaning one of the factors is negative. And in fact, it's going to be the bigger factor because of this minus sign. Okay, so let's go ahead and look and see which set of factors can make negative 3. And I scan 1 and 18, they can never sum to make negative 3. You can't play with signs and make negative 3 with them. 2 and 9, nope, can't do it either. 3 and 6, yes. If I make the 6 negative and the 3 positive. Okay, so that's what I'm doing. I'm choosing 3 and 6. I'm making the 6 negative. So I'll have a positive 3 and a negative 6 that go here and here. Of course, you could confirm this by foiling it back out and seeing if it gives you what you had. Looks like I've done it right. So now I'm going to proceed and solve. Now the zero product property says that if this times this equals 0, then that means this must equal 0, or this must equal 0, or both of them equal 0, right? So that's the zero product property. It is just saying that any one of these factors could be equal to 0 or both of them. And so to solve this, I'm going to take each piece, like the x plus 3, and set it equal to 0, and the x minus 6, and set it equal to 0, and I'm going to solve each of these small linear equations for x. So in the first case, I subtract 3 from left to right. And then I just found that that means x equals negative 3, right? Because I subtracted 3 to the other side. This stuff cancels. I have just found out that x equals negative 3. Great. And now I do the same thing with the x minus 6. So I add 6 to the other side. And, these pieces, they cancel. And my result is x equals 0 plus 6, which is 6. X equals 6. So these are the solutions. The solutions are x equals 3 and x equals 6. It says if there is more than one answer, give them as a comma separated list, right? So it tells me the way to answer it. So 3 comma 6. Sorry, negative 3 comma 6. Forgive me. All right, x equals negative 3, x equals 6. Okay, those are my two solutions. Great, and we found those by factoring. That's great. So let's go ahead and move forward to problem number 29, which says use factoring to solve the polynomial equation 4x squared equals 12x minus 9. Now to use this zero product property and factoring, we have to set the equation equal to 0. So the first thing to do is to, set it equal to 0 by subtracting some of this stuff to the other side. And so I'm going to subtract the 12x and add the 9 from right to left. That way this stuff cancels, that stuff cancels, it all equals 0, and I get a 4x squared minus 12x plus 9. That's the trinomial that equals 0. Great. And some of you might ask, why not just subtract the 4x squared from the left to the right, and then you've set it equal to 0. And the reason is because I do not want to have a negative leading coefficient. All right, so positive leading coefficient is definitely the way to go. It makes your factoring much simpler. Great. And that's why I subtracted 12x from right to left and added 9 from right to left. And now we're at this point, and I'm going to look at this and try to factor it. And one thing that I notice is I've got a perfect square on the left and a perfect square on the right. Yeah, so let me prove that to you. I've got a 2x squared, right? 4x squared is 2 squared times x squared. So we can call that 2x squared. And then 9 is 3 squared. And the middle term is it 2 times 2x times 3? What am I doing? I'm taking 2, multiplying by 2x, multiplying by 3. And then, 2 times 3 is 6, times 2 is 12. Yeah, that's 12x. So that equals 12x. And so I've just checked to confirm that, hey, this trinomial right here is a perfect square trinomial. And so I can write it as that perfect square trinomial. And I'm going to write, well, that's 2x and 3, right? 2x, 3. And then I see that there's a minus sign right here. That's a minus sign. That's why I'm going to put a minus here. If that had been a plus sign, I'd put a plus there. And I square it, right? Because I'm multiplying that binomial by itself, and that equals 0. Great. So I just took this trinomial. I recognized it as a perfect square trinomial using this stuff, right? This was a perfect square. This was a perfect square. This term was 2 times this times this. It all checked out. So I could write it like this. This is a great skill for you to have. I can't tell you enough how nice it will be for you to recognize perfect square trinomials. Students ask, could you factor it in a different way? Yes, you could use your other factoring skills like trial and error to do it. So you could try applying something different. But I'll tell you in the end, the easiest thing to do is to recognize, hey, perfect square, 2 times this times this. It makes life really easy. Because now we can solve. And so the answer, right, the answer to this question is x equals 3 over 2. Why am I saying 3 over 2? Well, because I look at the factor, right, the repeated factor, and I make this opposite and divide by this, 3 over 2. So opposite of the minus sign, right? Why am I saying that? Well, if I take 2x minus 3 and I set it equal to 0 and I solve it for x, I'm making the negative 3 opposite by adding it to the other side. And I now have 2x equals 3. right? I made that opposite. And then I'm dividing by this coefficient in front of x. Divide by that. Okay, so x equals 3 halves. And this is how I'm finding that answer. Okay, so you could analyze, you could look at this and say, make this opposite, right? Make this opposite, and then divide by this, divide by that. And so my brain looks at this factor and it says the solution for that x is 3 halves. But you could also set it equal to 0 and solve for the variable to find that same answer. All right, we're moving on to problem number 30, which says use factoring to solve the polynomial equation x squared minus 9 equals 0. And when I look at this, I see the difference of squares. Let me make it really clear for you. This is x squared minus 3 squared, right? X is squared, and that's minus 3, which is squared. 9 is 3 squared. Great. So now that I've written it like this, I can see the difference of two things that are squared. I can see the difference of two things that are squared. And so I factor it. Using our factoring skills, we've learned, hey, turn it into two binomials with x and 3 and x and 3, and put opposite signs between the two terms. Those are conjugates, and that's equal to 0. Great. And so now I'm going to write my answers, and I look what form they want it in. So I'm going to write x equals, well, this one is negative 3 because negative 3 plus 3 is 0. Okay, negative 3 plus 3 is 0. Okay, and then this x is positive 3 because 3 minus 3 is 0. So my two solutions are negative 3 and positive 3. Oh, but I can't separate by comma. What I'm going to do is I'm going to write x equals positive 3. There we go. This is how it'll want you to report your solution. So it'll be x equals negative 3 for the first one, x equals positive 3 for the second one. All right, problem number 31. And it says factor the expression 3x squared plus 7x minus 6. All right, so the goal is to take this expression, factor it. And I notice there's no GCF. And so I'm going to look at the first value, 3, and find its factors, 1 and 3. And I'm going to look at the last value, the constant, and find its factors, 1 and 6 and 2 and 3. There we go. And I need to figure out how to factor it, right? Here I have a 3x and a 1x, a 3x and a 1x, right? Those factors go with x. And I need to pick either 1 and 6 and 2 and 3 to make positive 7x as outer and inner terms. And when I look at it, you know, I see it's a plus minus situation, which means one of my factors will be negative. One of the factors is negative. So let's play with it for just a second. Let's say I pick like 2 and I make it negative. And so I'm going to try this one. I'll just see if it works. And so I jump in here and I say, well, if I make a positive 3 right here and a negative 2 goes right there, let's see if this works out. So I have a negative 2 times x, and then I have a 3x times 3, which is a positive 9x, and negative 2x plus 9x gives me positive 7x, which is exactly what I want. Great, it works. Make sure the signs match, right? I don't want negative 7x, I want positive 7x, and it looks like that works for me. Great. So I have just factored this trinomial into that. Great. Now it says for part B, solve the equation 3x squared plus 7x minus 6 equals 0. So it's taking the same trinomial, right, and setting it equal to 0. So I've already factored it, right? So I'll use that factoring 3x minus 2 times x plus 3, setting that factored trinomial equal to 0. And now I say, well, what are the solutions for x? Well, this x is make this opposite, divide by this. 2/3, right? 2, positive 2 divided by 3. And then this x, well, it's negative 3 because negative 3 plus 3 equals 0. It's negative 3. Done. We have solved. And I did it, according to the instructions, enter your answers as a comma separated list, right? I separated my answers with a comma. That's what it wants. Great. Hey, why does this work? You know why. Because if I took 3x minus 2 and I set it equal to 0 and I solved it for x, then I'd get 3x equals 2 and I divide by 3, so x equals 2/3. And if I took x plus 3 and I set it equal to 0 and I solved it for x, then I'd get x equals -3, right? So that's why these are the two solutions. Let's move forward. Problem 32, solve the equation for a. And it's factored, but there's a problem. It's not set equal to 0. And so we need to FOIL this and then add 5 to the other side to set it equal to 0. Let me show you the setup. So foiling, I get a times a, which is a squared. A times 3, which is 3a. 9 times a, which is 9a. And 9 times 3, which is 27. And that equals -5. Now, I'm going to add 5 from right to left to set this quadratic equation equal to 0. And I'm going to clean it up. I'm going to combine any like terms. So I have a squared plus 12a plus 32 equals 0. And now I'm going to attempt to factor it. So I'm going to, create the two binomials and put a at the beginning. A is the variable. We're calling it a instead of x. It's just like x, but it's a. And then I'm going to find the factors of 32, right, in a list. 1 times 32, 2 times 16. 3 doesn't work. 4 times 8. 5 doesn't work. 6 doesn't work. 7 doesn't work. It looks like these are all of the possible factors, right? So I have the list of possible factors. I love it because this is a plus-plus situation. It's really easy. Both factors are positive, and they have to sum to make 12. Right? So 1 and 32 don't sum to make 12. That doesn't work. 2 and 16 don't sum to make 12. But 4 and 8 do sum to make 12. We have found the factors that work. So I put a +4 and a +8 here. I didn't have to play with negatives because this was a plus-plus situation. Right? And so now since this quadratic is set equal to 0, I can solve for the variable a. And I can say that a equals -4 and a equals -8. And so why am I saying that those are the solutions? Because this a is -4. -4 plus 4 equals 0. And this a is -8. -8 plus 8 equals 0. Okay? And you could even set these pieces equal to 0 and solve for a. It's very simple, right? Like really fast. I could be like, okay, prove it. A plus 4 equals 0. So subtract 4 to the other side, and you find a equals -4. And then you have a plus 8 equals 0. And subtract 8 to the other side, and you find a equals -8. There you go. You have found the solutions explicitly. Great. Problem 33. Two numbers sum is 1, and their product is -72. Find these two numbers. Great. Let's call those numbers x and y. How's that sound? X and y. Love it. So if I take x and I add it with y, the sum is 1. And if I take x and I multiply it with y, its product is -72. Right? Great. Can you think of two numbers that satisfy these conditions? Well, what we could do is we could use substitution to answer this. So I could actually solve the first equation, like creating this as a system, right? System of equation. I know that was like 2 chapters ago, but that's okay. And so x plus y equals 1 can be rewritten as like y equals 1 minus x, something like that. How's that sound? Or you could say -x plus 1, however you want to. Or you could have solved it for x instead of y. I solved it for y. Whatever floats your boat. And now you could take this y down here in the second equation and replace it, right? Substitute with this, 1 minus x. So I can now write the equation, the bottom equation, as x times 1 minus x equals -72, like that. Well, why did I do all this? Because that allows me to solve for x. This equation right here, I can solve it for x. In fact, I'll do it. And so I'll distribute x, right, in here and here. And I'll end up with x times 1, which is just x, and x times negative x, which is negative x squared, and that equals negative 72. And this is a quadratic equation. But we want to set the quadratic equation equal to 0. So I'm going to add x squared from this side to this side, because I like my quadratic term to be positive, and also subtract x from this side to this side. And now I end up with x squared minus x minus 72 equals 0. And then I think, well, can I factor this quadratic, right? That'll make solving it really easy. And in fact, I can. And it factors to, well, 72 is 9 times 8, right? And that makes sense because I need them to sum to -1, so I'll do -9 and +8, like that. Cool. And so the solutions for x, right, are either +9 or -8. Because once again, 9 minus 9 is 0, so 9 is a solution, and -8 plus 8 is 0, so -8 is a solution. So I found two possible solutions for x. And at this point, I would then say, well, let's say x is 9. Okay, so if I made x 9 and I added y, which is -8, 9 plus -8 gives me 1, right? 9 plus -8 gives me 1, and 9 times -8 gives me -72. These are the two numbers, right? I have found the two numbers, 9 and -8. Awesome. So now our last problem, it's problem 34. Jasmine drew a rectangle with the following properties. The area is 32 square centimeters and the length is twice the width. Great, let me draw a diagram of that. So here's a rectangle and its area is 32 centimeters squared. And there's a relationship of the length and the width, right? So let's say that this is the length here and this is the width here. Well, the length is twice the width. It's 2 times W. Okay, so I can create a formula, right? The area formula of a rectangle. You all know it. You know that area equals length times width for a rectangle. And that's very useful to use. In fact, we can replace A with the value we know. We know the area is 32. So I'm going to replace A with 32. And the length, I can replace the length with 2W, right? Because the length is 2 times the width. So I'm going to call the length 2W. And I'm going to multiply that then with W, right? Because length times width is 2W times W. Great. So I have this equation now right here, and I can solve it for the width, right? So 32 equals 2 times W squared. And so what I'll do is I'll divide 2 from right to left, and I'll discover that W squared equals 16. 32 divided by 2 is 16. And then I will square root both sides, right? Because to undo squaring W, you square root. And typically we put a plus or minus sign for the square root property, but widths can't be negative, so I don't need the negative sign. I'm just going to say W equals 4. The width is 4. Okay. Now, lastly, now that I know what the width is, right, the width equals 4, then that means that the length is 2 times the width, 2 times 4, which is 8. But you know what they want for the final answer? They want to know what the perimeter is. Now, please recall the perimeter of a rectangle is 2 times the length plus the width, like that. Or some students like to write it as the perimeter is 2 times the length plus 2 times the width. Either way you want to think of it, that works, right? Because, just to get the second version, we would just distribute this 2 in Okay, so whatever floats your boat, I'm going to use the top one. And I'm going to say, well, the perimeter is 2 times the length, which we found is 8, plus the width, which we found is 4. So I'm going to have 2 times 8 plus 4, like that. And so 8 plus 4 gives me 12. And 2 times 12 is 24. And there we have it. The perimeter of this rectangle must be 24 centimeters. And we have now completed all of the chapter 5 and 6 review, all 34 problems. And here we did it. Great job, guys. Thank you so much. Have a wonderful day.